All right, y'all. So this is day 2 of section 2C. So no, not really necessary for you to go back and look at these unless you're lost after today. So what we're going to do is we're going to continue with the truck data from our last notes, the first part of 2C. So if you, that was this lesson. So if you don't have this data in your calculator still for L1 and L2, go ahead and pause it and go back and enter that data in there, okay? All right. So here's what this says. We are going to create our least square regression line by hand. And so step 1 of that is to enter all of your data into the calculator. Okay. So I know we're doing this by hand, but we're still going to pull some information off of the calculator. All right. So I probably need to check and make sure mine's there. Okay, yeah, so my L1, my L2 data is still there. So one of the things that I know from this data, and I'm going to write this down, is we already did this yesterday when we did the line. So I'm going to write my line down. So my Y predicted line is going to be 38,257 minus 0.163x. So when I'm finished, that's the line that the calculator told me that I was going to get, okay? So what we're going to do, we have to pull some information here. So because we have data in the X and data in the Y, so X is my L1 and Y is my L2, I am now going to run the report that I need. The data that I need is going to be in my second variable stats command. So I go into stats, go over to calc, go to 2 vars, 2 variables, and I'm going to run this L1 and L2. I don't need to save anything else, so there I go. Okay, so what I need here is that first thing that we're going to calculate is the slope. So I'm going to pull some things off that I need. I need the standard deviation in the Y. So if I look at my calculator, if I go down here a little bit, there I go. I have standard deviation in the Y, and I'm going to use 9570.42. And then my standard deviation in the X is 47,876.83. Now, this R value is the same R value from our LinReg. So yesterday, we had that value, shoot, I don't know where it is. Hold on, I'm going to rerun this. So I rerun my LinReg. There's my R value. Oh, that's right, negative 0.8150. So 815 was the value that we used yesterday, okay? So to calculate the slope, and let me show you something. You don't have to memorize these equations. So here is your AP Stats formula sheet, and you'll get this for every test and on the AP test. So we've done most of these now. So X bar, which is our mean, and we know that's the sum of all of our samples divided by the sample total. Our standard deviation, which we know our standard deviation is the distance. So our value, distance from the mean, we always have a positive number here to square it so we can take the square root. Here is our predicted line. So we have our Y hat line. And remember, this isn't MX plus B. We're using the stats formula now, so A plus BX. But this all means the same thing. So the A value is the value that is my Y-intercept. And then the B value is my slope. Well, here's my slope equation. So it tells me R over standard deviation of Y and standard deviation of X. And that's this formula that we have right here in our notes. Okay, so let's go through these other ones because we've done these. We're going to use this one today as well. And this says that the mean of Y equals the Y-intercept plus the slope times the mean and the X value. And this is an important line because your linear regression line will always go through this point. And I'll reiterate this in a minute, but the linear regression line goes through the point X bar, Y bar, okay? And then this is our R calculation. So we did the R calculation the other day as well. In your notes, we did this. So you have your coefficient of correlation constant that's right here. All right, so we'll go back to slope. So slope, same slope formula that's on your cheat sheet. It's right here. So now we have all the parts. We have our coefficient constant, we have our standard deviation Y, standard deviation X. So when I plug all this in, I would get negative 0.815, and if I divide it by Y, I'm going to plug this in my calculator. So what I get is I get slope, and remember slope is my variable b, of negative 0.1629, which is negative 0.163, which is what we got when we calculated it with the calculator yesterday. Okay, so far we're on the right track. So let's keep going here. So it says finding R. We could go through this process of finding R. We have the formula on your formula sheet, but you don't have to do it on the AP test, so we're not going to do it in class. You're going to just pull your R value from your Linreg regression, and you'll just use that R value. Okay? All right, so next thing. Find the y-intercept. All right, so what's really important is I'm going to skip down here. In fact, this is so important, I'm going to highlight it. Your least squares regression line will always pass through the point x bar, y bar. And remember what this means. So x bar is the mean and the x values, and y bar is your mean of the y values. And so the LSRL will always pass through x bar, y bar. So we can go back to our cheat sheet, and if we know y bar, and we know the slope, and we know the mean of x, so we know x bar, then we can find a, and a is our intercept. So I'm going to use the formula from your cheat sheet of y bar equals a plus b x bar. So this is the formula that we want to use. And if we're solving for a, so a is our intercept, so that's what we're solving for here, then all I'm going to have is I have y bar minus b x bar. So I move that over, and that's what I have. So I know my slope, it's negative 0.163, and I'm going to go back into my second var's calculation here. And I have my x bar, that's given, so it's 63,979.5, and then my y bar, which is 27,833.69. So those are my two values. Okay. Actually, you know what? I want to show you something. I just thought about something. So I'm looking at these values, and I say, okay, yeah, there's a big difference in the mean here. And I look up here, and there's a huge difference in the standard deviation. So let's just talk about this for a second. So let me get this data back out. So here's our data from the other day. And if I look at this, remember L1, miles driven, is my X variable, and my price is my Y variable. So if I look at my X variable, so we're looking at standard deviation right here. So I have huge standard deviation in X compared to Y. So if I look, miles driven, I have 70, 129,000, 4,000, 144,000. So if you remember, the definition of standard deviation is the average distance away from the mean. So if I look at these numbers, you know, 4447 up to 144,000, there's a lot of variation in there. So our standard deviation in X is going to be big. That makes sense. And if we look at our Y values, I have a low of 9,500 and a high of 42. But look at the majority of these values. 29, 41, 41, 28, 31, 37, 13 is a little low, but they're much closer. So it makes a lot of sense that our standard deviation in Y is a smaller value than in X. Okay? It's the same thing down here when I look at the mean. So the mean, the values are just larger in X than they are in Y. Okay? All right, so let's go ahead and finish this up. That's a little sidebar there. So my Y bar calculation, so here I have 27,833.69, and I'm going to subtract, actually I'm going to add, because I'm subtracting a negative, so I'm going to add 0.163 times 27, oh, sorry, X bar, 63,979.5. Okay, so let me just plug this all in the calculator here. Okay, so what I get, so I get my y-intercept, my a value 38,262.35. Okay, now if I look at what my expected value was, my expected value is 38,257. So 38,257 versus 38,262. And the difference in these two numbers is that everything's rounded. The calculator, when I did a LinReg, the calculator doesn't round it. Remember, the calculator pulls all the values, and these are all rounded values. So it makes sense. It's off by a little tiny bit, but that's not bad. Okay. So what does my equation look like? My equation is then going to be predicted y, so y hat is going to be 38,262 minus 0.163 x. Now I can change this around, and this is really what I want to do is I'm going to say this is my predicted price, and I have 0.162. This is going to be miles driven plus 38,262. And I know I rounded here. Oh, this is 163 actually. I know I rounded, but remember when you actually write this, you have to put your units in. So we're going to replace the y hat and the x with what we're actually looking at. We're looking at price and miles. Okay, now what it says here is interpret the slope in the context of this truck problem. So this was my slope value. So what I would say is for every mile increase, the truck depreciates. And if you don't know what that word depreciates means, that's a word you should know. That means goes down, and it's a value of something, a house, a car, but the truck depreciates 0.163 or 16 cents. Now, I know with miles, we would say, with money, we would say 0.16, but I think in the context of this problem, it would be okay for you to put 0.163. I mean, you might just say here, like I did, 16 cents, right? Super important that the decimal's where it needs to be. Depreciates because it goes down. If the cost was going up, it would be appreciates, all right? So that's all there is to it. I know that when you look at the formula sheet, it looks crazy, but really that's all it is. You don't have to memorize these formulas. They're going to be given, but you do have to know where to get the values, and that's going to be with this second VARS stats. Okay? All right. So we won't at school use statistical software. We can do everything on your TI-84. But it's important that you know how to use Minitab or JUMP because you might see these on a test and you're going to be asked to interpret from the software. So what happens is you'll see just a printout that looks just like this. It'll say constant on there, and then it'll give you whatever your X value is going to be. So it's going to be in terms of whatever the context of the problem is, all right? It is never going to tell you that this top value is intercept and the bottom value is slope. You just have to know that. So you have to go in and memorize these two, and they're always in the same location. It's the same thing over here. The y-intercept is the top one, the slope is the bottom one. And this is what the printout looks like with this statistical software. Okay, so there's nothing that I can tell you that's going to help you remember that, except for you just have to remember that. Y-intercept's first and slope is second. And if you remember, actually, if you think about this, the intercept's first and our slope is second. And this is the format statistically that we want to use, right? We don't want to use mx plus b, we want to use a plus bx. So what you see first is the intercept, which is first, and the slope is second. So hopefully that helps you. What you also pull out of this is you see the standard deviation. You see your r squared. That's this value, r squared. And then this r squared adjusted, we will never use that. So you can get rid of that. let's see, what else do I want to talk about? I think that's it. We're going to talk more about all of this in another section, but I think it's important in terms of trying to calculate this. So here's a question, and it says, a random sample of 15 high school students was selected to investigate the relationship between foot length, so how big their foot was, and their height. And so here's a statistical printout. So here's a mini tab printout. So what we know is that this value is going to be my y-intercept. So this value is going to be my a value. And this value right here is going to be my b value. So that's my slope. And then it says the mean foot length is 24.76. Well, this value right here is my x value. So foot length is my x value. So I can go in here and I can say x bar equals 24.76, and s of x is going to be 2.71. The mean of heights, so y bar, that's my heights, is 171.43, and my standard deviation of y, so s sub y, is going to be 10.69. All right, and it actually even gives me my r value, which is 0.697. Okay. So one other thing is this gave you the r value, but I've seen it where it doesn't give you the r value, but you can find it. Remember, this value is r squared, and so if r squared is 48.6, and that's a percentage, if I took 48.6 and made it 0.486, and that's my r squared value, and I take the square root of that guy, then I get this value of 0.697, which is what my r value is. So you will always have r squared on your printout. You usually don't have r, but it's super easy to get it. If you need it, you just go take the square root of r squared. Okay? All right, so, and what we're doing here, I guess I didn't finish this, is we're creating our line by hand. That's what we're doing. Okay, so first thing I know is that my b value, my slope value, is r times sy over sx. And actually, if you think about slope being change in y over change in x, this just makes sense too. So my slope value is going to be 0.697. Oops, wrong one. 10.69 over 2.71. So 0.697. So 2.68. Oh my gosh, I'm having a brain fart. 2.668. 658. Holy Shannon, 2.658. I'm gonna change this because that's gonna kill me. 2.659. That's really what it is. Okay. All right. So I found that, and now I need my intercept. So my intercept is going to be y bar equals a plus b x bar, and I have everything that I need. I have 171.43 equals a plus my slope, which I just calculated, 2.659. times my x bar, which is 24.76. Okay, so 171.43, and I'm going to subtract my slope times my mean, and I get that A is 105.59. All right, so when I put my line all together here, I get 105.59 plus 2.659 times x. Now I'm going to change this so that it's perfect and there's not going to be any question on this. I'm going to say that the predicted height is 105.59 plus 2.659 times foot length. Okay, so it would look like this. All right. Okay, last question that we have here. So this problem says, we have a computer output summarizing the relationship between the maximum wind speed and the minimum atmospheric pressure for hurricanes and major hurricanes in the Atlantic Basin. So we've got this printout. It's got everything in here that we know. So let's look at this. We know that this value here is going to be my intercept. Oh, actually, let me look at this real quick. I bet you I calculated my slope wrong. 0.697 times. So this should be 2.749. I was having problems writing that down. Okay, that's why this number's off a little bit. I didn't even think about that. So here's my y-intercept. I should have 103.41, and the value that I got here was 105. And the reason that's off is because when I plugged this in my calculator, I somehow got the wrong number, 2.749. Okay, so that goes back to checks and balances. That's why I realized I made that mistake because of this question right here. So this is my y-intercept, which is my a value. This is my slope, which is my b value. This is my r squared. So my r squared, so I can find my r value, which is 0.879. So 93.75, 0.9375. Okay, so let's see what this question's asking us. What does the residual plot indicate about the linear model? So remember, for us to have a linear model, it has to be completely random. And so this is random. I know it looks like we have a pattern right here, but we know that we don't want it to look like a parabola. It can be an up parabola, it can be down parabola. We don't want it to look like this. Now, it's kind of looking like that a little bit over here, but what I would say is that this has random scatter. In the residual plot. So it's a good approximation for the relationship and this is where I bring the context in between max wind speed and minimum pressure. All right, so if we saw one of these patterns, then we would say that it's not a good residual plot, so it's not a good approximation, it's not a good least square regression line, but because we don't see any random, because it's random, then it is. All right, next one, interpret the coefficient of determination. So coefficient of determination is my r squared variable. So it's super important that you remember the difference between r and r squared. So that's my r squared variable. And so what this is saying here is because it's 87.9, I can say 87.9% of the variation in max wind speed is accounted for by this least squares regression line. All right, and then this, interpret the standard deviation of the residuals. So we haven't really done this very much, so this is a good one to look at. So I have from my computer printout, I have the standard deviation of 8.99. Now that is not, because this is two variable data, this is standard deviation of the residuals. So this plot is of a residual plot. So this is the standard deviation of the residuals. If it was a standard deviation of x or standard deviation of y, you would see that, s sub x or s sub y. This would tell you which variable that you're talking about. But when I see this, this is just the standard deviation of the residuals. So what we would say here is that this value is s on my, this value is s on my table. So I would say the actual wind speed is typically 8.99, because that's my value, 8.99 miles per hour. Standard deviation has a unit. So miles per hour, why do I say miles per hour? Let's make sure I understand this. I don't have miles per hour. That's minimum pressure. I'm going to assume miles per hour. I'm going to put that unit on there, miles per hour. Away, so actual wind speed is typically 8.99 miles per hour away from the predicted least square regression line. So if you think about, because this is the standard deviation of the residuals, that is going to be what's away from the line. So I have my least square regression line, and then I'm going to have my points that are going to be above and below this line. And so when I'm looking for the standard deviation, it's the distance away from this least square regression line. But remember, it's away from the predicted value. So the actual wind speed is 8.99 miles per hour away from the predicted value on the least square regression line. So some might be above, some might be below, but we're looking for the value away. So what I don't say that's different than our other standard deviation is I don't say above or below. So there's no above or below on standard deviation residual plot. Okay. I think that's it. Okay, y'all, I'm so sorry I messed up the slope on this problem. It threw all my numbers off, but I'm not going to redo the video. You can see this. This number was off. It should have been 2.749. When I redid it, I got this value. And then that puts my intercept off a little bit because this value should be 2.749. So my y-intercept should have been 103.41, which put it off a little bit from this one. So process is the same. I made a calculator mistake, and so it threw all my other numbers off, but I'm not going to redo this. You can figure out what I did. Okay.